Okay, now we're going to extract two principal components, the first one and the second one, and then plot them. And this is not necessary for doing the principal component analysis. This is just another example to understand some functions that are available in R, and also the the notion of missing values that we use to na.omit. So now this example gives you some more insight into how to deal with those missing values. Okay, so we're going to extract um, the two first two um, principal components from PCS3, the one that we computed with scale dot equal to true. So uh, PCS2 plot. Yeah. So we're going to now we're going to create a data frame. So we'll do a data frame. Okay. PCS3 okay, $X. Okay. We're going to now get all the rows of the first column. All right. And then we're going to get PCS3 $X all the rows of second column. Okay. That should be the column. Then we want to also get the names of the serial. So we want, okay, like see, remember the first column is name. Okay, so we want to plot the first PC1 value and the second PC1 value with the names of the serial. But there is a problem here, okay, and that is PCSDF. Okay, we created that previously, which is with only two variables, but that's fine. Oh, 7 variables, sorry. That has only 74 observations. So this also has only 74 observations. We can check that. So you say length, right? PCS3 $X. I mean, comma, on all rows. So you see 74. But serial has 77. Why is that? Well, that's because there are some missing values. So you can do a missing value. So you know how to figure out the number of missing values, right? Column sums with the isNA serial.df will tell you how many missing values there are there in each column. So we have one missing value, one here, and two. Well, obviously, in one of those rows, there are two missing values in a row. So there's totally only 3 rows with missing values, obviously, because we have 74 observations in the principal components. So we need to omit the rows. Okay, when we get the names of the serials, we need to make sure that we only include names that have no missing values in the row. So how do we do that? Well, there is a function for that, and that is called complete cases. So if you say complete dot cases, and then you say serial dot df, so that will give you, okay, yes or no, true or false for each row. So each row, whether it is true or false. So here is a false, here is a false, and then there is another false. So we can use this to mask the names of, so put up, press the upper arrow and then you can do this. So we can say serial dot df, okay, and for rows, whether they are complete cases or not, and then we can say 1, okay, serial dot df. I made a mistake here. Serial dot df. So that gives you the names. Okay, so this is the 73rd row. It's not that there are only 73. See, these are the row numbers that are selected by the true false. Okay, so that's the reason why you have that. So what we can do is, so we have to put that code. Okay, so let's go here, press the upper arrow, and then we can copy that, press escape, so that's gone. So now we'll go here and, well, that should be like that. Okay, and then we'll close parenthesis. Okay, so now let's run that, and you see that's created PCS to plot as 74 observations. Now they have the Z sub 1 values, Z sub 2 values, and then the name. But the column names are crazy, so let's go ahead and give nice column names. So here we'll say names PCS to plot C. We could have given the names here itself, but anyway, Z1, Z2, name. All right, so now we have the data to plot. Then we'll go ahead and plot. So ggplot, okay, PCS to plot AES x equal to Z1, y equal to Z2. Okay, so then we want now if you say geom point, okay, so at each of these coordinates between z sub 1 and z sub 2, okay, so you'll have a point. Okay, so you have a point. Okay, but instead of point, if you say text, right, geom text, and then you use geom text is again what you're going to plot at those points, and you give that as an aesthetic, and that is labeled. We're going to, at each of those points, we're going to plot a label, and what is that label going to be? That label is going to be the name from this data set. Name is okay, that's the third column there. So now you see the names are printed and they are running into each other. So we can say, all right, so let's go ahead and say size equal to 2. That's a little bit better, and we can try to angle it a little bit. So we can say angle equal to say 30, Oh, that's a little bit better than before, wouldn't you say? Then there is another one called check overlap, and so we say true for that. Then let's see what happens. Okay, so that makes it even better than before. Okay, so it gives you between the two principal components where each of the serial falls. Okay. But that's not very practically. It's not very useful. But what the concepts that we covered here is how to plot, okay, instead of points in a scatter plot, plot the names, and how to do overlap, and how to angle, and that kind of